Okay, and let me start telling you something about JavaScript. By the way, this cheat sheet that I found can be also useful. It's downloaded somewhere. But anyway, these are the, well, I don't know, some of the most common JavaScript functions and methods as a quick reference, but we'll start, of course, from the characteristic of the language. So let's start with a bit, with 3 minutes of history, because we must understand where things come from to understand why they are so ugly in some places. Okay? So let's assume JavaScript is a programming language. Let's see how it works. And a programming language also, of course, has a runtime environment that is able to interpret that. So first of all, JavaScript is an interpreted language. We have an interpreter, not a compiler. We don't have binaries. We only have source code. Okay? Node.js is a runtime environment that is able to run JavaScript programs in a console environment or in a server environment. And every browser, Chrome, Firefox, Safari, whatever, Edge, whatever, it contains also a JavaScript interpreter inside. So we have many interpreters of the language. We hope they are consistent. We hope they interpret the language in the same way. There may be some differences, of course, like, for example, some function for handling mouse input or user clicks cannot be implemented in Node.js, in a console application, in a server application, of course, because there's no mouse, there's no user there. So there are, of course, some differences in the supporting libraries, but the language should be more or less aligned. More or less because the different developers work on a different speed in implementing the language issues. And so JavaScript, okay, we have the version 2025, version 2024, and so on, but every JavaScript version is a moving target because it depends on whether a given feature of the language is implemented or not by a specific browser or by a specific server environment. It happens, especially with the new features, that some browsers implement them before than others, and so on, and we should keep them into account, trying to use the language features that are implemented by the majority of the browsers. And there's a lot of libraries and say, solution for the so-called transpiling. So taking some JavaScript code which is written with the latest features and translating it to other JavaScript code, not to binary, that doesn't use those new features and they just implemented with the older version of the language. So actually, in many cases, the JavaScript you write is not exactly the JavaScript that will be run by the interpreter because there's a translation step in between. We won't go deep into this, but when we are going to work on React, we'll see that what we are writing is not exactly just pure JavaScript because it involves some translation steps. But, well, I don't need to brag about JavaScript being one of the most popular languages in the world, because actually it's mandatory for every web application, so actually it needs to be there. I think the most important point of this slide is that the first version of JavaScript was written in 10 days by one person. Okay? And combined with some background compatibility that we also always want from a programming language, it means that also today, many years after, we still have in the language some design decisions that were made by one person in 10 days in a hurry. So there are some issues in the language that are not going to go away, and that seems silly now that JavaScript is a full feature language and very popular and so on. But at the beginning was just one engineer trying to write some scripting capability into Netscape Navigator. I don't think you already used that, maybe heard but not used, to do some fancy animation inside the web pages. It was just totally a marketing issue for making web pages visited by Netscape users fancier than those visited by Internet Explorer users. Chrome was not born yet at that time. Okay, and this means that this dates back to the 1995. Were you even born then? No? Okay. And this Brendan Hike is the original author. And it was a language that was put inside a version of the browser, Netscape Navigator at the time, which is the forefather of Mozilla Firefox, Netscape Navigator. And you see that there was some, it was a language built inside one browser. If you were a website developer at that time, would you use a language in your web page that only works with one browser and not with different browsers? Well, at the time, the answer was yes. There were many websites where say, okay, this website is best viewed with Netscape Navigator, or is best viewed with Internet Explorer, something that today we cannot imagine. But of course, different browser developers, there was no mobile browser at the time, of course, different browser developers try to implement the same language, so that a website with some nice animation or nice features could be visible, could be used by by all the browsers that they were outside. And so they felt the need of writing some sort of standard. Okay, there was a standardization institute in Switzerland that nobody heard of before, called ECMA, ECMA. We say, okay, let's standardize this. And they wrote some documents, ECMAScript version 1, ECMAScript version 2. They couldn't use the name JavaScript because it was trademarked by Netscape. So they said, okay, this is the ECMAScript language, and they tried to put some specification to them for the basic construct of the language, okay? And then people implemented them, browser implementers tried to follow more or less the specification. They were not really strict specification. They were. By the way, at that time, Microsoft said, okay, I don't like using that language. Let's use my own language. They called it VB Script. It was based on Visual Basic, totally incompatible, only worked on the Microsoft browsers. So that was a very, very early times in which people didn't really know in which direction they went. And then the standardization effort stopped for 10 years. Of course, development didn't stop, but every browser developer went their own way. They tried more or less to copy what the others were doing to make a language that was nearly compatible, but not totally compatible, so that they could have some sort of advantage over the others. Okay? It's a chaotic times. After that, after 10 years, there were two versions of the standard. One, it was ECMAScript 5, ES5. That was the first version that recognized that some design choices were wrong, and they introduced what today we call the strict mode. So it's a mode of interpretation of the language where some bad constructs are forbidden, and the syntax is a bit stricter and also is a bit clearer. And starting from then, they tried to work with a group of different developers, and the first real nice version of JavaScript with classes, modules, all the functions that all the features that we are using today went out in 2015. Let's say it took more than 5 years to agree on a modern version of JavaScript. So basically, ES5 was the old version of JavaScript described, standardized, and year 6 is the modern version of JavaScript. It was 10 years ago, and now every year or every couple of years there's a new update coming out with some details, something new, of course, but it lies on the main foundation of the object-oriented JavaScript, which is known as EX6 or ES 2015, or basically modern JavaScript as they call it. So we are of course targeting this version. We don't want to go and dig back, but of course sometimes the history surfaces with some weird behaviors. Okay, this is the boring document. If you want to download it, it's really very hard to read. Okay, and as I say, different JavaScript engines, JavaScript interpreter can implement different functions in different ways, different functionality in different ways. That is where the MDN website, the Mozilla Developer Network, comes in very handy, because for every language feature, it lists for the different features, different details, different methods, and so on, and for the different browsers, desktop or mobile, which is the minimum version that can run reliably that feature. And so if you see something which is, of course, Internet Explorer is dead, so I'm not fancy, I'm not surprised that everything is black, but if you see one row which is basically green, means that it's a feature that can be used. Otherwise, if you'd better maybe not use this feature because it will not be accessible to users. Okay, this is just for advanced features. The basic features, of course, are already there. You can get this information from the MDN website, or there's also a website called caniuse.com, and it tells you the compatibility between different browsers. So, as a language evolving since 30 years, of course, there's the issue of compatibility. The choice was that JavaScript is backwards compatible but not forwards compatible. What does it mean? It means that if I'm writing some code today, okay, the future version of the language will not invalidate what I'm writing today. So if I write something today, and the syntax and semantics of the language can only add new things, but not break what I wrote before. So see it in reverse. If today, 2025, we go into a website where there was some JavaScript code written 15 years ago, we expect that code to work. Okay? But it's not forwards compatible, because if I write some code today and I try to run on that code on a browser which is 15 years old, it won't run, probably. Okay, so I'm writing code today that works on browsers today, and I have the guarantee by the language designers that will also work on browsers tomorrow. But I cannot expect that modern, say, more recent code could also work on older browsers. You can ask yourself, why should anybody want to run it on older browsers? Well, if I have millions of users, I never know what they are running today. But it's in design of the language. The only exception to this rule that did break backward compatibility was the strict mode, that for now, for us today, it's normal. And we have since we have all this version running around, we have these tricks about transpiling, or sometimes polyfilling, so having some library that provides some function written in JavaScript that in newer version are already predefined in the language. So there are a lot of tricks to try to mitigate the ecosystem, so that when I write code, let's get the tools manage about the discrepancy and the gaps between the browsers and not the programmer. So the programmer can target one language. Okay, this is an example of the different runtimes. In this course, we are using Node.js, as I mentioned, both from command line and from server environment, and of course the engine that runs in the browser. I also suggest this website called JavaScript Tutor, which is in the website called Python Tutor, because it started with Python, which is very nice because it will show us with pictures the data structures or the values of the variable that we are defining. So initially, for understanding the data model, it's quite useful. So let's keep it open for us. It gives you from some code, it runs the code, and it gives you a pictorial representation of the data. And I find it useful to help me create a mental model of how the values work, okay? Especially when you have some doubt about, when I'm learning some new data structures. Let's see what happens. Okay, and then we can run it in the console, or we can run in Node. Basically, let me open this. We can run some code interactively just by opening this Visual Studio Code. Let me zoom it a bit. Okay, Node is an interpreter of the language, and so we can directly run some instruction by running Node and having a prompt in which we can write code. So for example, let a equal to 7, and see what is the value of a, which is 7, of course. So we can run instruction interactively, or we can open a website and write some code there. Sorry, I was playing yesterday. And run the code. Sorry, let me save. I forgot to save. And run the code here, or from the run button here. Run into Node, and it will sorry. Okay, it prints 7 because it's 3 plus 4. We get to that. Okay, so in developing, basically, we can write our script into a file and then run the file, or when experimenting, we can just open a terminal with Node inside and interactively test some statements, or testing them onto the JavaScript tutor as I mentioned. So let's keep it open so that we may experiment with what we are learning. Okay. Logically, the interpreter sees a JavaScript program as only one big file, even if there are language constructs, of course, to split the program in different files with modules or with functions. We'll see them. The file is first parsed and then executed. This means that if you have a syntax error, you will find it immediately before running the first instruction, and not just when the interpreter comes to the real instruction. Okay, this is different from Python, for example, where the syntax error is only detected at the execution point. And we should be careful about what is the language itself and what is its standard library. Some constructs are from the language standard, and some are from the libraries, the basic standard libraries. Why? Because the standard libraries are different in the different environments. As I mentioned, the environment for a server is different from the environment from a browser, so the libraries themselves, they have some common parts, but they also have some parts that are dependent on the environment. So we should be a bit aware of where the APIs are coming from. Very quickly, the syntax of JavaScript looks like C or C++, because language constructs are separated by, the language blocks are separated by curly braces, and comments are C++-like comments, and so from at first view, the syntax is similar, no, to C and C++, with the exception that semicolons are optional, nearly always. Not always, but nearly always. So that the interpreter is normally able to understand when a statement finishes and then when the next one begins. And so basically we'll insert the semicolon by itself. And a lot of programmers are just using this to avoid typing the semicolon themselves. Okay, there are only some couple of cases where the semicolon is mandatory, basically when there should be an ambiguity how to interpret the next line. We'll see that. Actually, if the next line starts with an open parenthesis or an open brace, square brace, then the interpreter cannot tell whether this is the beginning of the new line or the function call, for example, or an array indexing of the previous line. But it's very rare that we start a statement with an open parenthesis. Okay, so normally it doesn't happen, but when in doubt, it's always good to add a semicolon, also for readability. If you leave them out, usually you're not making any damage. As I mentioned, we will not even look at the older version of JavaScript language. We'll write all our code in so-called strict mode. And there are two ways of telling the interpreter that we want to use strict mode. The first way is to write use strict semicolon in the first line of my program. Syntactically, it's just a string, okay? It's a string that is being evaluated and thrown away because I'm not doing anything with this string. I'm not printing it, I'm not storing it into a variable, and nothing else. But it will trigger the interpreter to switch to strict mode. Another way is but this only works in Node.js, to call your file. Normally, a JavaScript file is a file with an extension .js, JavaScript. In Node, you can also use the extension mjs, where M stands for modules, so modular JavaScript, that will tell Node.js, the interpreter, that we want to use the new module syntax, which is also implied by strict mode. So it will automatically switch on the strict mode. So you either write at the beginning, use strict, semicolon, or call your files with the extension mjs, and so you will be programming in strict mode, or both. Okay, it doesn't do any harm. Remember to do that for all of our files, because otherwise we can fall into all the bugs that were solved 20 years ago. Okay, so what does the language look like? This is the type system of JavaScript. Okay, first of all, we are talking about types for values and not types for variables. So when I say that the syntax is similar to C or C++, well, this is a semantic point which is totally different. Okay, so we are used in C++ or Java that variables are typed. When you declare a variable, you should always declare the type of that variable, or the values that the variable will hold. Here, we don't. It is more similar to what Python is doing. Variables do not have types. Values have types. So a variable is just a pure reference, a pure placeholder that refers to a value, and that value has a specific type. No type declaration on variables. Every object has a type, but they are the objects, not the variable referring to them. So, but if you're familiar with the Python, for example, it's the same concept. So what are the possible types for values? Well, we have a handful of primitive types plus an object type, that, of course, with all the structured types. Primitive types are very few. String, number, and Boolean. That's it. Well, there are two special types that are null and undefined, which behave in a strange way. And they can be useful. They will be useful. These are the only 5 primitive types in the language. You see that we have, okay, string is no surprise. It's just an immutable sequence of characters in Unicode, encoded in Unicode. And they can be syntactically written with double quotes, single quotes, or back quotes. Single and double quotes are the same. Back quotes are useful for string interpolation, as we see. So they will be our interpreter, are more powerful. Number is just a one-type number for both integers and floating point numbers. There's no distinction between the two types, the two types of values. They're all number. And it means that also there will be implicit conversion between the two domains of real numbers and integer numbers. Actually, the interpreter will switch to real number whenever it needs, so when there's a fractional part or when the integer will become too large to represent with a given number of bits. We don't know which is the word length, whether it's 32 or 64. It's implementation dependent, but we shouldn't care, in theory. Boolean only has 2 values, true and false. And then we have all the object types. Object types we have 2 different types of objects that are predefined by the language, called array and function, plus all the other user-defined types that may be defined by the user itself or in a library, of course. I don't know, the date object is an object which is in the standard library. But it's not part of the language itself. It's part of the library, of the standard library. Part of the language are only arrays, square brackets, that are flexible. It's not just like C arrays, because they are a very dynamic data structure, or function, and we'll make a lot of friendships with JavaScript functions as objects by dealing them as objects or as values, because there's a lot of gimmicks that we are going to do with functions. So functions in JavaScript are really objects that we can pass around, we can modify, we can refer, and so on. So there will be a lot of functional programming, which is the standard way, let's say, the standard idioms of JavaScript programming are based on using functions and passing them around as objects and calling them asynchronously and so on. So this will be probably the most interesting part of the language. About the Boolean type, these are just very basic things, but we need them to get started. There's a type Boolean with 2 values that are true and false with the lowercase t and f. Okay? But there are also many implicit conversions from all the other types for all the other values to Boolean. So whenever we need a Boolean value and we have a string, or we have an array, or we have an object, or we have anything else, it will be automatically converted. So JavaScript is doing really a lot of automatic conversions. Whenever we have one value of a type and the language, in that point, it needs a value of a different type. So first of all, it will try to convert it. And the rule is strange, because the values that are false, or they convert to false, are, of course, the constant false, and these 5 values. 0 is false, minus 0 is false, not a number, none, which is a number. Not a number is a constant of type number that comes out when you do some division by 0 or some illegal operation like that. It gives you this result. Is false. Undefined. So undefined is the only value of a type undefined, is treated as false. Null is the only value of type null, which is undefined, false. And the empty string is also false. These 5, we need to remember them. Everything else is true. And an empty string is false, but an empty array is true, or an empty object is true, or an empty function is true, but an empty string is false. This is an exception that always makes me uncomfortable, but that a number different by 0 is true is normal. We have in all the other languages, so 0 is not a surprise, but the empty string here is an asymmetry. So usually we call truthy all the values that are true or convert to be true, and falsy all the values that are false, the false constant, or they're converted to be false, which is actually these 5 values. And as I mentioned, JavaScript is always trying to do conversions before operations. Okay? So, for example, where do I have the terminal here? If I'm trying to check whether 3 is equal to 4, it's false, clearly, and 3 is equal to 3 is true. But what happens if 3 number is equal to 3 string? In this case, it's true. Because what JavaScript is doing here is saying, okay, I'm trying to compare a number and a string. This can be done, so let's make a conversion to make them possible to compare. And so we will basically convert the first 3 into a string and then do the string comparison. And you see it for equality, you see this also for arithmetic operators. 3 plus 3 is 6. But if by chance this 3 is a string, then it becomes 33. Because I have a number of a string, I cannot sum them. So let's convert the number to a string and then use the addition, which now becomes string concatenation onto them. Okay, so the language doesn't check the types, doesn't do type enforcement. The values do have a type, and the operators check the types and try to carry on the operation without getting errors, without throwing exceptions as much as possible. And so they will try to do conversions. In many types, they do conversions in a reasonable way, but sometimes it can be a surprise if you are not sure, if you didn't remember, okay, to convert numbers to string and so on. So normally, every operation will first try to convert the types and then do the operation, with one exception, which is the strongly equal sign, 3 equal signs, equal, equal, equal. That's only for comparison, doesn't work with other operations. In this case, it will prevent the type conversion before doing the comparisons. So in this case, 3 really equal to 3 as a string is false, and of course it will be true if this 3 is a number. Also, you see that 3 as an integer and 3 as a double is the same number, because they are types of the same object with the same value. And so when doing comparison, the suggestion is think whether do I want a conversion, a type conversion or not. And normally the answer is not, and we'll use the 3 equal signs in our code. But also remember that in all other let's say, operators, the conversion will take place. The undefined and null are something that will be, okay, we'll define them here, but we'll see them when you have, for example, optional parameters in a function. So it's a variable that has not been defined because the parameter has not been passed. There's a lot of, again, flexible interpretation of the language that leads us to be able to pass some values which are not really defined. And so these are undefined means some value which is missing. Null and undefined, just a definition, are also called nullish values because they behave like a null, null or undefined. But let's see them, we'll see them in special cases how they work. Okay, variables. How to define a variable? In JavaScript, there are 3 ways to define a variable. The first one is using let x equal to 5. This defines a new variable and it gives it the value on the right hand side, 5. Now here not prints undefined because the result of the expression doesn't give a result, doesn't give a value. Okay, so this undefined is not the value of x, but is the value of let as an instruction that doesn't compute any value. If I see x now is 5. Of course, I can change x to something like that, and the value, of course, as being updated. Variables should be only defined once, because if I try to redefine it, it says that the variable, the name x has already been taken. So the let instruction creates a new name and assign an initial value to it. Can I write something like that? Yes. It's not suggested. I'm creating a variable without assigning an initial value to it, without initializing it. Stupid, probably. Okay? But the syntax allows it. So let is the normal way of declaring a variable. And then we can update the variable as much as we want. The second way of declaring a variable is using const. Z equal to 5. No, 55. Let's change the number. So Z now is 55. The only difference between let and const, you guess that Z cannot be modified. If I try to assign a new value to a const variable, I get an error. Otherwise, they behave in the same way. So a const variable is bound to always have, for its lifetime, the value that was assigned during initialization. A normal variable declared with let sorry, may change its reference anytime. And many times also means that x was an 8. I can later on say that s will be a string, and it doesn't get offended. It works. We are just changing. X is just a reference, remember, a pure reference, a pointer to a value. We are changing the value that this variable is pointing to. It may be point to any other value of any type. Now x can be an array of 3 numbers, and this is. Okay? While z cannot be, the const variable cannot be changed. So I said that there are 3 ways to declare a variable. I only described 2, let and const. Actually, there were 4 ways. The other 2 are var and none. In the first version of JavaScript, you could just use a variable without declaring it. And in strict mode, this is forbidden. So let's not use it. Means now in interactive mode, it's still valid. So if I write something like t equal to 6, it will create a variable called t. But normally in strict mode, it's forbidden. If I write some code here and try to say here t equal to 6 and run this code, so I save and run, it will tell me that t is not defined, okay? Because in strict mode, all variables must be defined. Must be defined with let or const, or also with var. Var was an old declaration. We don't use it very much because it's similar to let, with the difference that the declaration is hoisted. Hoisting is a word that I didn't know before. It means lifting up, okay? So actually, a declaration with let declares the variable in that point where the code is executed, so the variable will exist from that point forward. A variable declared with var, we declare the var with in line 20, but actually the JavaScript interpreter will move this, will move this declaration up to line 1. So we declare it as we go, but the declarations are processed before the rest of the code. And it gets more complex with that because it depends whether you are inside a function or not, and so on. So it's a strange behavior where a variable is existing even before you declare it. I don't find many uses for that. No? It was the old, say, way of declaring variable. It's still supported, but normally it's much clearer. The semantics is much clearer with let and const. Okay, variable is declared in the point, starts to exist in the point in which it's declared, and it ceases to exist when the enclosing block is finished. Okay, with the square braces. So we'll try to use these two ones. Only one warning: since variables are just pure references, a const variable, so declaring something with const, prevents this variable to point to some different value, but it doesn't prevent the value from changing. Okay? If, like I had before in the terminal, I can declare a constant variable list of 1, 2. Okay, so the list will be an array of 2 elements. We don't know the arrays yet, but just bear with me for a moment. I cannot redirect the variable to something else, but I could do something like adding a new value to the list itself. So the variable list can change. It's a const, cannot change. So you must always point to that list, but that list itself can be mutated. We can add and remove elements or sort it or so do something with the object value. We cannot break or change or remove the link between the variable and the object, but the object itself, in this case it's an array, can mutate. So const is a property of the variable and not of the value. Okay? Okay, so this is an example where we see different behaviors between let and var, but I don't want to spend too much time on that. The only thing I want to show is that if we have a variable declared with var in some place, actually is the definition here is move up there, without, of course, initializing it, because we cannot say c is equal to a times 2 at the beginning of the code. So we first declare the variable which will be uninitialized, so undefined, until we reach the real point of definition. That's strange enough that we don't want to waste our short-term memory about this. Let me check the time. Okay, so I think we can make, because we went a bit long, we started a bit late, but I think it's time to make a short break and then do some exercises with some operators, some expression. Okay? So how about 15 minutes? 10:40?